Well, welcome Year 12s. I'm going to do a video for 3 of the suvat equation questions from 17b. You could pause the video in a second and just read what it says here on the page, so you know where we're working from. Clearly help if you've read those questions, because they're going to be the ones I'm doing. So you may want to pause the video now and read those. Right. The way you start all suvat questions is write down what you know. So in this case, we have a car accelerating from rest 12.45 meters a second. We know u, we know v, and we know the time it takes. The question wants us to find the acceleration. So, which of the suvat equations uses v, u, v, t, and a? V equals u plus at. Rearrange it to make a the subject. Always write down the formula. Okay, you're going to get marks for that. Put the values in, get an answer. Book does it 3 sig fig. I've done 2 sig fig. Why have I done it to 2 sig fig? Because time was the 2 significant figures here, so I don't think it's appropriate to go more accurate than that. Okay, second part of the question, they want us to find the displacement. Now we could use a, and we could use this equation, for example. But remember, we calculated a. It might be wrong. It might be an approximation. So better would be to use u, v, and t, which we know are exactly correct. So use u, v, and t, calculate the, in this case, distance she travels since she starts from rest, and the acceleration is positive, the displacement where she ends up is equivalent to the distance travelled. Right then, question 4. In question 4, a particle reduces its speed, so it's decelerating. So I'm expecting a negative acceleration. So question 4, the constant acceleration, because she's slowed down, it should be a negative one. Again, state what we know, what we want to find, pick the appropriate suvat equation, either substitute, rearrange and solve, or rearrange, substitute, solve. And as we said before, importantly, that's negative, okay? Because it was slowing down. And then find the distance the particle travel in another 5 seconds. Well, in another 5 seconds, what was the previous v is now the u. Okay, time is 5. This time we have to use the acceleration we've calculated. And that's what's staying constant for the remaining time. What connects ut, a, and s? S equals ut plus half at squared. Soak under tap half a square tea bag. Substitute the values in. Get an answer. And again, if we go back to the original question, we had 3 sig fig, 2 sig fig, 3 sig fig. Well, it's not definitely 3 sig fig that even, is it? It's 120. So I think 2 sig fig for the answer. Right, final question I wanted to go through on this video. I wanted to go through question 8. So in question 8, just reading the question here, car reduces its speed from 18 to 9 while travelling 200 meters. So reduces its speed. So we've got an initial speed, a final speed, but remember their velocities when they go into this, okay? So a velocity of 18, a velocity of positive 9, a distance travelled of plus 200, and then the question wants to, how much further will it travel before it stops? So when u is 9 and v decreases to 0, we want the s. We're told the acceleration stays the same. So let's find a and then use it. V squared is u squared plus 2as links u, v, a and s. That gives us this acceleration. Now in this case, since we don't have to quote that, I'm going to keep it in that form, which is exact. And then I'm going to use, it's v squared is u squared plus 2as again. Same values. Put those in, work it out carefully. 67 meters. Right, 2 sig fig, 1 sig fig, possibly 1 sig fig there. 2 sig fig or 1 sig fig would be appropriate. So 70 or 67 would be appropriate. Right, I'm going to now make a video on the motion under gravitation. It'd be really good if you could read the examples for vertical motion under gravity and also try all the other questions in 17b. Okay. As a reminder, the formula are in the formula book. You don't have to learn those, but it is handy to know them. Right, let's stop the video and save it.